GM everyone, or good afternoon or good evening, depending on which side of the planet are you in. Here is Steve, our QA from zkVerify, and I'm Milica. I'm DevRel and PhD candidate in ZK. And today we'll be presenting you zkVerifyJS library and its possibilities and how can you use it in our hackathon. Steve, can you tell us more about the library you personally wrote to help developers?
Sure. Hey, everyone. So essentially, we've created this zkVerifyJS package just to abstract a lot of the complexity that you would see at the lower level when dealing with proof verification and its interaction with the zkVerify blockchain. So what we'll be doing today is just going through a brief bit of the documentation for the package on the NPM website, and then also going through and running a starter command, an npx starter command that will pull down a very simple web app and shows the integration with zkVerify by sending some hard-coded proofs using all the different proof types that we currently support.
So it's for our developers to see and learn how can they in a very I saw this Steve presented this to me before, but it's very easy where everything you have to do is connect your wallet and submit your proof, and that's it, like all the magic. So okay, I will add your slides so that people can see what we're talking about actually.
Okay, right, let's do it. Right, so we've done I think a couple of these presentations in the past. The key thing to know is that our latest version of zkVerifyJS was published last week, so 5 days ago, and that included some new functionality and some slight adjustments to the way that you would interact with zkVerify. So what I'll do first is just very quickly go through our npm package. So as you can see at the top, this is just as per all the packages hosted on npm. Very simple install command, npm install zkVerifyJS. And we've made a lot of effort here to ensure that the documentation is as complete and easy to understand as possible. But as always, please feel free to use it, feedback, and let us know where we can make any improvements. Okay, so very briefly then, so I guess this is described as a TypeScript library, essentially an abstraction layer, as I mentioned, that allows you to send proofs to zkVerify for verification, wait for transaction details, listen to events, and perform a number of other actions. So currently, we support a number of proof types, as you can see here, and a number of them we also support different curve types and different libraries. So, for instance, Graph16, if you had created them with Snart.js or with Go, then obviously there's slightly different format for the proofs. And we've very recently added support for many of the versions of RISC-0, which has also meant that there's a slight change to how the proof data is sent to us. So you can see here we currently support version 1, 1.1, and 1.2 of RISC-0. Then we've also got UltraPlonk and Space and Time's proof of SQL. So we'll quickly scroll down then. So obviously I already mentioned the installation, nice and simple. Then the concept would be to connect to our network by creating a session. At the moment, we've got one pre-configured network, which is our testnet. Simply calling this command, start with testnet, will connect to our network and our RPC nodes, enabling you to start sending your queries and your transactions. We've also got the ability to connect to a custom node. So this would be used if you're running your own node, and also enables you to perform some functionality that might not be available on testnet, but we will get to that. I guess we'll say there's kind of three types of sessions. So you can connect that to the testnet just by itself, and that will be considered a read-only session. You'll be able to perform some read-only actions, but you won't be able to send transactions or send any proofs to us. The two other options then would be to connect to the network with an account. So you would use a secret file, for instance, on backend server to connect to the network with a wallet, or you connect using with wallet, which enables all the functionality that you would expect for a dApp on the front end, connecting with any of your Chrome extension wallets. So at the moment, for instance, for zkVerify and us being a substrate-based chain, you would use something like Subwallet or Talisman to connect on the front end, but we'll also demonstrate that in a short while. So let's quickly scroll down then. There's the ability then to send a proof to zkVerify can be seen here. Everything's been written in a fluent syntax. So you specify your proof type as part of the session. So any of the proof types that we support, you can add some optional commands here. So you can obviously specify the nonce. You can choose to wait for the attestation to be published, which essentially means that an event is fired on zkVerify and the proof is published to its destination chain so that it can be checked. So, for instance, on Ethereum. And you can also state that you're using a registered verification key, which is done to reduce costs for sending a proof with the same VK again in the future. And then the three main parts of the proof data being the public signals, your proof, and the verification key. Again, we will try not to go through too much of this, but as a very brief overview, the documentation covers things like how to register a verification key and use that in the future for submitting proofs. How to listen to all the various events that are associated with sending a proof to zkVerify, which you can see here, or how to set up all the different listeners and log the event details. Awaiting the final transaction result. So you have the capability to wait for it to be included in a block, wait for it to be finalized, and obviously you can decide at what point you want to utilize that data and confirm that it's actually been verified successfully. One of the newer bits of functionality that we've added, this is currently only available when connecting to a custom node. We've called it optimistic proof verification, but essentially is a wrapper around the dry run functionality on Substrate, which I guess would be also similar to something like ETH call, where you're able to run the transaction without it being included in a block and without it having any cost associated with it. So dry run requires a node to be running with certain flags set, the unsafe flags, as essentially these are potentially leaving your node open to things like denial of service, where someone could send a lot of transactions if it was open to everyone. So again, just be mindful. This is something that you would more likely use privately and with a node that's not exposed to everyone else on the internet. So this essentially gives you a very, very quick response back for your proof verification. So within milliseconds, you can have a response back that confirms that the proof data that you've sent is valid and has been verified. So where you could use something like optimistic verify would be to quickly send it to your node, get a very quick response, continue on with your logic, safe in the knowledge that when you send it properly and have it sent to the network, that it will succeed and it will be mined and it will be finalized. So this is just something that's provided to try, obviously, speed up the feedback for yourselves and for the users. And we've got some example code there also. At the bottom of the documentation is all the API reference for all the different commands you can use, which I'm not going to go through for this particular stream. But yeah, any further questions on this document, feel free to send them on Discord or Twitter, and we will answer them as best we can. So that's essentially the first part of this stream, a very quick run through of zkVerifyJS on NPM. And we will go through the starter template and how to get up and running with a very quick web app. Did you have any questions there, Melissa?
No, I'm just carefully listening to everything you're explaining, and yeah, I cannot wait to see how it works. Because I'm a visual person more, so let's see how it looks like and how to run it.
Okay, awesome. Right, so hopefully you can see my code here.
Yeah, I can.
Okay, right, here we go. So let's see if this zoom works. Here we go. That's not
Yeah.
Well, there is it. It's not zooming in on the right place. It's not great, is it? Right. So, come on. Let's try this one. Right, okay. So we've got a command here. This is an npx command that I believe is in our documentation. Essentially is a command that will pull down some code that we have in GitHub, creates a very simple Next.js website, installs zkVerifyJS and all the other necessary packages, and then will inform you exactly what you need to run in order for you to view this in your browser and get things running. So what I'm going to run here, this npx command, is going to start up a new starter project, and at the end here, we're giving it a name, which I've just called my new zkVerify project. So if I run this, you'll see that it starts to pull down everything, installs the packages. and will eventually tell us what we need to run to start the app. But lucky for us, I have prepared one earlier. So what I'm going to do, why is it cd test1, and simply all you should need to do once the install is done is a yarn run dev.
Yeah, it even says after you have all of the npm packages, it even suggests what command should it run, if I'm not mistaken.
That's right. So this is actually finished. That was pretty quick. So as you can see, to get started, cd into the new directory, and then yarn run dev to get running. So what I'll do now, I will just quickly swap between screens. Okay, let's just... there. Right, sorry, let me figure out what's going on here. Okay, star up, share. Okay, so we can see this, I hope. Yep. Right, so super simple. We'll go through the code after this as well. Essentially, all this app is demonstrating is how to connect a wallet on Substrate and how to submit a hard-coded proof to zkVerify for verification. So we can go on. We're going to connect a wallet. Hopefully I'm just double checking that's all coming onto the stream properly. Select a wallet. So we've selected a wallet, we're connected, and we're simply going to click the submit proof button, which is going to cause our wallet to pop up and approve the transaction. And then in the background, we can see that it's sent the transaction to zkVerify. It's been included in a block. We get block hash back. And now we're just waiting for finalization. And there we go. So now we've got our message back to say that the proof was successfully verified. This particular one was a risk0 proof. We'll take a look at the code in a second. We get a transaction hash back, the proof type, and we've got what we call an attestation ID.
So yeah, it has like all the info which we should have. And it's so simple, just like a couple of commands and like a couple of clicks, and you actually submitted a proof to zkVerify. Like, thank you, Steve, for making devs' lives easier.
Yeah, so thank you. So that's the... Obviously, this app is very much simplified. It shows you how to get your proof sent over to us, how to get those details about how it's been, whether it's been successfully verified or not. You can then view that on our Explorer, as you would expect on any block Explorer. You can see that it does actually exist. So what we'll do now is we'll quickly run through the code again. Let's see. Okay, so let's get into the code then. Super simple. I'm not going to go into too much detail with kind of all the filler and the buttons and everything else, but essentially we've just got a home page with all the usual code that you would expect from a front-end perspective. We have the connect wallet button functionality, which again, if you pull down this project, can obviously be useful if during the hackathon you're creating something that needs a wallet to be connected. And then we have the main connection to zkVerify, which is just a very simple hook that's been created with a lazy loaded package. And we'll just quickly go through the code that's being written here then. So as we looked at on the documentation, we're connected to our pre-configured testnet, and we're connecting using the with wallet command, using the selected wallet source. So for instance, if you had Talisman or sub-wallet installed, plus the account that you selected when the pop-up appeared, this would be passed in, for instance, using an account context like we've got here. So as the wallet details are selected, we ensure the context is set. That's then utilized in the hook. And then very, very simply, we have the execution step. Once we've created the session, we're specifying some proof data. So for this particular one, we're verifying a risk zero proof. We're providing some data here with the proof, public signals, and verification key. And one of the new features we now have is the ability to specify the version of risk zero that you're using. So this field is now required for risk zero, and is dependent on the version that you have installed and that you're using. We then have an event listener. For this one, I think we're purely looking for the included in block. And then we're awaiting the transaction result, which essentially is the finalization of the transaction in the block, and setting the result so that we can display it on the front end. So that is a very simple app and overview of how to send something to us. If you pull down this starter project, we have a number of hard-coded proof JSON files that you can see here on the left-hand side. So FLONK, your Graph16 with the different curve types and the different library that's used to generate them. Proof of SQL, we've got a risk 0 1.0 and a risk 0 1.2, and we also have an ultraplonk JSON there. So you can kind of quickly see how this would be done in terms of the code. What can go wrong doing a bit of live coding, essentially. If you, for instance, wanted to use Graph16, you would change that value here to be Graph16, and then we are passing in a library. So let's say for this particular one, we've created a proof using Snark.js, and let's import that as well. And we also need to specify the curve type. So we'll say BN254, and again we just call the exact same execute command. We pass in the relevant details from one of these JSON files. So at the moment, for instance, we are very simply importing that on one of the other pages, I think, and that's being passed in here. And then also for this one, for Graph16, we don't provide a version, so this is an optional field. So essentially, that is the change you make to send a Graph16 proof. Some of the other ones are even simpler. So if you are going with ultraplonk, for instance, there's no library, there's no curve type. So essentially, your command to execute and send to zkVerify is exactly that. So session.verify followed by the proof type, and then a final execute call containing your proof data. So Anyone pulling down the starter app, feel free to run it as it is, which will send the original RISC-0 hard-coded data, but have a play around with taking some of this data from the proofs folder, and you should see that every single one succeeds, and it's that you're able to send all these different proof types with their variations to zkVerify for verification. And that is essentially that. A very quick crash course in zkVerify and zkVerifyJS.
Thank you, Steve. I think that's something our hackers actually need. And one question that I might have is there kind of a list where they can see which proof types require library and curve type and which ones do not?
Yes, there is. So that's currently specified on the in the documentation. So as soon as you go onto the NPM website, there's details on there. You would also expect to get an error back if you try call anything and something's missing. We've tried to design this so that the feedback that you get as a developer is pretty clear, and if you don't think it is clear enough, then as always, let us know and we'll make some improvements.
We're here for all the critics, good or bad. Everything to improve the developer experience.
Absolutely.
Yeah, so okay, we'll look out for the questions to answer them and everything. We're in Telegram, Steve and I. We're also in Discord to answer all the questions. And yeah, anything that you want to improve or you have a comment on, please let us know. Thank you, everyone. Bye-bye.
Bye.